Hello friends, so we are here again with a new problem, arithmetic slices to subsequence. So let's see what is the problem and try to understand this problem. So what actually the problem is, we have given an integer array which is nums and we have to return how many arithmetic subsequence we can find from this. So, what is arithmetic subsequence? Before that, you have to understand what is AP. Okay, so let's take an example and see what it is. So, if I'm taking this part, so what is AP? As you know very well, AP is the common difference. If we have a series of number, so the common difference of that number should be equal. What does that mean? So you can see there is a series of number we have, and the common difference means if we minus 4 minus 2, which is equal to the 2, and if we minus 6 minus 4, which is equal to the 2, then we can say the 246 is a arithmetic progression. So the problem is we have an array, and from that array we have to find how many AP we have, right? Now, there is one more thing. If you have two numbers, let's suppose there is a 2 and there is a 5, we can't say that it is an AP series. Okay, why? Because yeah, 5 minus 2 is 3, but how we can say this is an AP series? For an AP series, it should be of 3 length. If there is 6 and the 6 minus 5 is 1, yeah, we can say this is not an AP series. So in this problem, the valid AP series is of length 3. So how we can approach this problem? So the first approach, which is a very brute approach here, and its time complexity is in the exponential form. In this, what we can do, we can take this 2, put in some array, and then we are putting in 4, and its common difference is 2. Then we put 6, and its common difference is again 2. And this is actually exponential because for each element we are taking the number of elements we have, and this is a very like the complexity of this problem is very high. And if you see the constants here, so this is 1,000, and if you solved in 2 to the power n, so 2 to the power 1,000 is a very much high, which is not which can't be solved here. So what is the beautiful approach, or what is the right approach to do it? Okay, so the right approach is, just wait, let me add a photo there. There is problem. Import, export. Just wait. I have something for you. Yeah. So what we can do in order to solve it, we are creating a hash map for each element in our array. What does that mean? See, we have to find the AP series. And what is AP series? AP series means same common difference. So from there we can say we don't have to think about how we create AP series, but we can take the help of a common difference here. It means if some sequence of elements have a same common difference, we can say that it is a AP series. Similar thing we do here. What we did, for each element, as you can see, this is 2, 4, 6, 8, and 10. What we did, we are at this position, and there is another pointer which is at the fourth position. Now we subtract 2 minus 4, and its difference is minus 2, and this is 1, which is the frequency, which tells that how many times this minus 2 comes up. So this is the first time and it comes first time. So in the hash map, we have a key value pair. Here the key is the common difference we have and the value is the frequency for that common difference. I think you get it. That what we are trying to do, we are finding each and every possible common difference and from that we take only those common difference having length greater than or equal to 3. Okay, so let's see how we can do it. So this is a sequence which is a 2 and 4 and it comes only one time. Now just make this pointer to 6 and the j again starts from the 0 because for 6 there is again that all that combinations again. So we are checking 2 minus 6 which is minus 4 and this minus 4 common difference comes first time, that's why its frequency is 1. Similarly, for now this j comes to that 4. Now 4 minus 6 is minus 2 and this minus 2 is coming second time and we get to know from the map, from the dictionary we use. From the dictionary we can check if this minus 2 common difference is already present or not. So it says yes, it is present. So we what we can do, we can simply increase its frequency by 1. So here the frequency is 1, here we make it frequency by 2. Now we are checking all these things. Now after that what we will do, we simply make this pointer to there and we make a j pointer to there. Let's suppose this is an I pointer and this is a j pointer. Similarly, 2 minus 8 is minus 6 which comes first time, so its frequency is 1. Now the j comes to this position and 4 minus 8 is minus 4 which comes second time, so we make it its frequency by 2. Now the j is there, so 6 minus 8 is minus 2 and this comes third time, so its frequency is 3. Now the similar stuffs work again and again and how it works, we are at this position and we are at this position. For 10, let's see what is the common difference we can get. So for 2 and 10 there is minus 8, for 4 and 10 there is minus 6 and this comes second time, for 6 and 10 there is 4 and for 8 and 10 there is minus 2. Now from there what we can say, we have to only take those series having length greater than or equal to 3. So if this minus 2 common difference comes 4 times, we can say, how we can see, if we have let's suppose 2, 4, 6. So 4 minus 2 is one common difference. 6 minus 4 is another common difference. So we can think for that. Okay, but here you can see we just want the element greater than or equal to 3. So the common difference which is a minus 2, it comes how much time, it comes 4 times, so we can take it because it is greater than or equal to 3 and this one is also greater than or equal to 3. So the total AP series we get is 4 plus 3 which is 7. Let's see. So yeah, there is total 7 that we get. So how we can code it? See, what we did here, for each element you can see we create a hash map, we create a hash map, we create a hash map. Sorry. Now we what we did here, we are at ith position, then we are creating a jth position and the j move till I and this I position moves for the n elements and this jth position move less than I. So this is somewhat we can say for n elements we are iterating n minus 1 another loop. It is a big O of n square time complexity. So similar stuff we did. Let's see the code. So the code is very easy. What we did here, So simply what we did here, this is our array, and this is our answer, or we can say the total number of subsequences we have, and this is our DP array. What we did in the DP array, see, for each element, as I said here, for each element we create a hash map, and here the counter is nothing but it is a inbuilt library which create counters for each and every element. Now the same stuff works here. For each I, we move j, and the j should be less than I. That's why its range is I. Now what we did here, a simple stuff. See, uh, okay, what we did here, uh, sorry, let's suppose my I is there and my j is there. We create a common difference which is 2 minus 6. Okay, so what we did, we find a common difference. You can say I minus j or j minus I, doesn't matter. Okay, but if you did a I minus j, so you have to follow this in everything. So if you get a common difference, sorry, uh, if you get a common difference which is 2 minus 6, which is minus 4, okay, what we will check, we will check if this minus 4 comes first time or it is already there. So we find the common difference, and if this is this is the hash map for all the element, because j is always less than I, and whatever the j we have, it is already computed, right? It is already computed. So what we did here, we check for that difference, if that difference is already present or not. If it is, so whatever the frequency it contains previously, we are adding plus 1 to it, and if it is not present there, then it should be only 1 because it comes first time, and it is pushed into that hash map. Get it? Because I is 6 and 2 minus 6 is minus 4. So we search in all this j. Is minus 4 is present? No. So we make it 1. And where we put this key value pair? In I. The same thing. Where we put in I. And we are just make a total of all the difference that we get, and we have to return that total. You can see the solution. Okay, you can see this solution, and the solution which is that I am saying square root solution is, let me show you that one as well, uh, where I can do it. I think where is my previously submitted problems. Mhm. uh-huh. This is the run submission result contribute. Mm, 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 where it is, I have to go there. Okay, there are all the submission. Yeah, you can see this is the solution that I previously talked with you. Let's go to submission there. Okay, so this is the solution that I used previously, but its time complexity is too much, so we have to use hash maps, and for that, time complexity is often square. I hope you get it. If you don't get it, my recommendation is try to dry run once, and it makes more clarity for you. Thank you, friends. Bye bye.